All right, Math 3 students, this is the video notes for page 328. It's going to start with problems like that. We're just going to work through a couple of them here to get you a handle on them, and then hopefully that will help you with the rest of them. So before we even jump into that, though, I think it's helpful to jump into something like 20 or 50. The idea is the same, it's just we have x's and stuff like that. So if you have 20 or 50, the idea is what goes into both of them. So 2 goes into both of them, 4 goes into both of them. But if you find the biggest one to start with, that'll save you some time. So that's what we want. We want the greatest common factor. And the greatest common factor here is 10. 10 divides into both of those. So you can say it's 2 times 10 and 5 times 10. Okay, so 20 is 2 times 10, 50 is 5 times 10. 10 is the common factor here. If I put parentheses around them to group them, you can just cancel those out, because 10 divided by 10 would be 1. So you'd end up with 2/5 times 1, or just 2/5. Okay, so that concept's the same, except for now we have x's and stuff like that. So we come through here and look at 2. 2 has something in common with 4, but doesn't have anything in common with 3. That's not going to help us. But all of them, if we notice, all of them have x's. Okay, these two have 2 x's, but this one only has 1. So the smallest number of x's is just 1x. So I'm going to rewrite this as 2x squared. I'm going to write it as 2 times x times x. The bottom, because it has 2 terms, is going to have to be factored. The common factor with both of them is the x. So if we pull the x out, that's x times 3x minus 4. Because x times 3x gives us 3x squared. X times 4 will give us the 4x. Okay, so seeing these as separate factors, now we should be able to see 2 times this, and then x times this whole thing. Well, x and x cancel each other out, and now we see what's left. On top you have 2x, on the bottom you have 3x minus 4. At this point you're done. Okay. Now you might be tempted to take the x and x and say, oh, you can cancel those. You can't. The reason why is because these have x's, but the 4 doesn't. It has to be in common with all of them. So even though x is common with these two, it's not common with all the terms. So that's that. Okay. So that's where we're at for the first one. Okay, for number 3. They do get a little harder, and we'll work through a couple more examples. And so with each one, try and use that as a guideline for the other problems. Yeah, so when you get to number 5, it gets a little bit trickier. We got things, you don't see any numbers in common with all of them. So x and x, but this one doesn't have an x. 18 and 6 have something in common, but 7 doesn't have that in common. So 6 goes into 18, but 7 wouldn't go into 18. So that's not going to help us. So what we got to do to make this not so overwhelming, cover up one part of it. Okay. And so what we're trying to do here is we're trying to get this into 2 factors, like that. The way we do this is go back to factoring and review those notes, because we're going to do lots of it here. X squared is going to be x times x. The 18, well, it might be 9 times 2, but that won't combine to make 3. Okay, 18 and 1, same thing, won't combine to make 3. But 6 and 3, we can combine them to get a negative 3. In order to do that, we need, in order for this 18 to be negative, we need a negative 6 and a positive 3. Because when you add these together, you get the negative 3x. So again, what we're checking here, we set these up. These are our factors, but we check the cross product. The cross product gives you negative 6x and positive 3x, which gives you negative 3x. That's our middle term. That's how we know this one works. Okay, so I'll move this up here a little bit more so you can see. So this whole thing here, the factors are x minus 6, x plus 3. All right. We'll do the same thing with the bottom side. Okay, so we're going to go ahead and cover up this whole bottom. Sorry, cover up the whole top. And then if you just look at the bottom side, we should be able to get that into factors. So take a second, look for factors that multiply to make 6. It's not 2 times 3, because that will never give you 7. What it is 6 and 1. Whoops, but I messed up here. It's a negative 1 and a negative 6. And here's why. When you distribute these, you get a negative 1x, negative 6x. That gives you the negative 7x. Okay, so make sure you factor this right. Use some scratch paper and do the method we showed up here and we did in that other chapter. And when you remove everything, you should have 2 things in common like we do here. So x minus 6, those are now common factors. You can cancel the entire thing because this is one factor times another factor. This whole thing is one factor times another factor. Cancel entire factors, and then you're left with just x plus 3 over x minus 1. And that's it. That's as much as you could do. You cannot cancel the x's, so don't even try. Just leave it like that. All right, so those should help you get through a fair number of them, okay? Later on problems will have multiplication, but it's still pretty much the same, okay? So let me just give you a short note on that. If you had something like x minus 5 over 2x, and then this one was 5x squared over 3 times x minus 5, let's say. When you multiply this whole thing, it's kind of like before. You put the whole thing together as one fraction. The 2 times this 3 will give you 6x, and then you'll have x minus 5. And you take this one step at a time. So we took this multiplication and wrote it as a single fraction. Now common factors will cancel out, and you're left with 5x squared for 6x. Oops. Now, from there, 5 and 6 won't reduce, but you have single terms here, just x and x. One's x squared, one's x. So really, if you wrote this as 5 times x, and this is 6 times x, well, then those x's will cancel, and you're left with 5x over 6. So that was just a general example, but the other problems in the homework should be similar to that. So use 3 and 5 here to help you with the other ones, and bring lots of questions on Tuesday. All right, and have a great weekend, everyone.